Hello everyone, you are preparing for your next examination in schools. So you might have some problem in understanding Cartesian product, relation and function. All these are related and you can say that the topic relation function belong to the set theory only. So what is Cartesian product, what is relation, that will be revising with you the concept, and then we will solve some worksheet problem based on Cartesian product and relations. So suppose you are defining this manner, Cartesian product from set A to set B. Cartesian product of set A by set B. Suppose there be two non-void sets. Initially let us start with two non-void sets A and B. Then A cross B will be the set of these ordered pairs where A comes from set A and B comes from set B. For example, if we have A equal to say XY and B equal to PQR, then in A cross B we will have elements like this: XP, XQ, XR, YP, YQ, YR. Now a question arises, what are all these things? What we are writing there inside the first bracket? First bracket in terms of interval, that we know if it is from A to B, it is x greater than equal to A, less than equal to B. Variable can take values in between A and B, but A and B are not included. But when you are writing this here in Cartesian product, then this AB will represent a ordered pair. What is an ordered pair? Ordered pair consists of elements or two components. Ordered pair has two components. First component comes from set, the first set. Second component comes from set B, from the second set. So in ordered pair, we are pairing the elements from set A and set B. Here in these ordered pairs, we have paired the elements of set A and set B. Set A elements are the first component, set B elements are always second component. Now how many elements are there in A cross B? This A cross B will be NA multiplied by NB. So this is 2 into 3, that is equal to 6. So there are 6 elements of A cross B, and or better to say, A cross B consists of 6 ordered pairs, and we can count number of ordered pairs always by this formula: number of elements in A into number of elements in B. So if we have two sets, let NA equal to N1 and NB equal to N2. Then what about NA cross B? If you follow this manner, or if you use little bit concept of fundamental principle of permutation combination, NA cross B going to be number of elements in A, number of elements in B, because two methods will occur simultaneously, they always come together. That's why number of elements in A cross B will be N1 cross N2. Now in these ordered pairs, sometimes we need to compare two ordered pairs. How to compare two ordered pairs? Comparison of two ordered pairs. Two ordered pairs can be compared if the first component of the first ordered pair equals with first component of the second ordered pair. Similarly, second components are comparable. So if we have AB equal to CD, then A equal to C and B equal to D. You must have studied all these things, but little bit revision required before you start solving problems based on it. Comparison of two ordered pairs we have learned, and then like ordered pair, ordered triplet also there. How to define ordered triplet? This ordered triplet will be of this form A, B, C. Okay. So ordered triplet, if we write set A cross set B cross set C, then this will give us ordered pair this manner A, B, C, where A belong to first set, B belong to second set, C belong to third set. It happens this manner. So ordered pair and ordered triplet concept you understand. And another thing, now I like to discuss with you that what is the relation will be defined from set A to set B. Relation is also a correspondence. Relation also can be termed as a correspondence between elements of two sets. So when you are writing a relation defined from set A to a relation defined from set A to set B is a subset of Cartesian product set A cross B. Okay. So this relation you can term as R. One can say that, can you write this manner? R is a subset of A cross B. You have to write this. R is always a subset of A cross B. Any subset of A cross B you take into consideration, that will be relation, correspondence between elements of two sets. Okay. Now let us start with the simplest example here. Let A equal to say 1, 2 and B equal to 2, 3, 4. Then how many elements will be there in A cross B? That you all know. A cross B will contain 2 into 3, 6 elements. 1, 2, 1, 3, 1, 4. Then 2, 2. 2, 3 and 2, 4. So number of elements going to be equal to 6. Now out of these 6 elements, you take any 2 or any 3 or even 1. Even if you don't take any one, that is going to be a relation from set A to set B. So if I write this thing, R be the relation 1, 2, 2, 3, 2, 4. I am correct. Why? Because I have taken elements of A and B in the form of ordered pair. Now all the elements, all the first element belong to first set, all the second element belong to the second set. Now this relation states what? Actually this relation states that how the elements of first set related to the second set. Right now there is no other significance, just they related, that we can see element of first set related to element of second set. 1 will taken from here, 2 from here, 2 taken from here, 3 from here, 2 from here, 4 from there, like this. And if you go by arrow diagram, then this is set A, set B, 1, 2, 2, 3, 4. That relation is 1, 2, 2, 3 and 2, 4. This is the arrow diagram I have used to represent the relation. And this time, if I try to define domain of this relation, dom R, this is going to be the set of the elements taken as first component. What are the elements taken here? 1, 2 and 2. You cannot take repeatedly words or numbers. So it is 1, 2. Dom R is 1, 2. And you see they will belong to this set. There, in fact, it is equal to set A only. But remember, domain R is not always equal to A. Then what is range of this relation? Range of R, since all 2, 3, 4s are used, it will be 2, 3, 4. Alright. So range of the relation is 2, 3, 4. This way you can define domain and range of relation. Now I would like to explain the concept of this domain and range by taking one more example from this set only. Suppose I am taking let R1 equal to 1, 3, 1, 4 and say 1, 2 also there. Is this a relation? And what is the domain and range here? Obviously this is a relation because all the elements taken from either from set A or set B, I mean not elements, components of each ordered pair. So this thing is 1, 2. We have taken 1, 2 is there, you can see 1, 3 and 1, 4. What is dom R here? Dom R will be equal to 1, 2 because these two are taken here, and range R will be what? This will be equal to 2, 3, 4. Now let us apply the concept we have learned so far in solving FOI sums like this. Like write the ordered pair whose first entry is 7 and second entry A. This is going to be 7, A. Now it is given AB is particular ordered pair whose first entry is a constant, second entry is a vial. State true or false. It is false, obviously. This particular ordered pair first entry is not consonant. Instead the second entry is consonant and the first entry is a vowel. So this is false. Write an example of an ordered triplet whose second entry is a multiple of 3. Second entry is a multiple of 3. First entry, not stated anything. Just they asked you to write an example whose second entry is a multiple of 3. You can write it in this manner, just ordered triplet. It is of the form A, B, C, you know. They have asked you to write second entry is multiple of 3. You can write A, 3n, C. And this n belonging to multiple of 3 means it may be an integer. So in the form of ordered pair, in the form of ordered triplet, you can write this manner. A, 3 and C where n is belonging to I. Next one, just comparison. Two ordered pairs are equal if corresponding elements are equal. So this is going to be 3x equal to 9. So x3 and y equal to 2. Next one also you can get by comparison, x plus y equal to 3 and y equal to minus 7. Solve x and y. And for this one, A cross B union C, if they have asked you to find, you just write B union C what? This is nothing but 1, 3, 4, 5. So A cross B union C, this is going to be 1, 2, 3 cross 1, 3, 4, 5. So this thing is 1, 1, 1 3 1 5, then 2 1, 2 3, 2 4, 2 5, 3 1, 3 3, 3 4, 3 5. Have I written right correct number of elements over there? Yes, because here there are 3 and 4, 12 elements. So this is 5, 4, 9, 3, 12 elements are there. Now these two are equal ordered pairs. State true or false. Just compare and get the value. This is false because x is coming to be equal to 0 here and y is going to be minus 5 plus 1 by 3. Y is correct, but this is wrong. So statement as a whole is false one. This is not correct. Now let us see what happened in sum number 8. Set A has 3 elements, set B has 4 elements. How many ordered pairs can it form so that first entry belongs to set A and second entry to set B? This is just number of elements in A cross B. A in A cross B is going to be NA multiplied by NB. This is equal to 12. And for this one, x is equal to 3 because x plus 3 is 6, so x will be 3. And 2x plus y equal to 5 because second element equal to second element. 2x plus y, not 2x plus 5. 2x plus y equal to 5. So y equal to 5 minus 2x. 5 minus 6, that is minus 1. In sum number 10, they have asked you to find the two set, find A and B. They have asked you to find the set A and B. See how to find it. A is given, B is also given. You need to find A and B. So first element always always taken from the set A. So what are the elements taken over there? This A is taken, B taken, A again repeated, B again repeated. So you see there is variation in these two only. I mean, they are being taken once or twice or thrice like that. So A contains these two elements only, AB, and B contains which elements? 1, 3, 2. So just write in order 1, 2, 3. Finished. Sum is done. Now this 11th one is very interesting. That it is given that ordered pair 5 to belong to this set, state whether true or false. So 5 to belonging to this set, it means x will be equal to 5, y will be equal to 2, so 2 will be equal to 5 minus 5. Is it true? Since this is not true, so 5 2 does not belong to R. 5 2 does not belong to R. Since 2 is not equal to 0, it's a wrong statement. It is false. Then number 12, A given, B given, R is this represented relation from the set A to B, whether true or false. See, we check whether just the first elements A, B, C taken from first set or not. No, C is not an element from the set A cross B. I told you the first element should belong to this set. So your answer will be like this, as C does not belong to A. So this statement, this is a relation from set A to B, is false. Now A given, B given, how many relations? This is very easy. How many relations will be there? This let me explain. To find number of relations from set A to set B, you need to find A cross B first. What is A cross B? That you all can write now. This is A1, A2, B1, B2. So in A cross B is NA into NB. We got 2 into 2, This is equal to 4. So how many relations possible from set A to set B? It is from set A to set B. How many relations? Number of elements in A cross B you found. Any subset of this will be a relation. You know, if a set contains n elements, number of subsets is 2 to the power n. So here the set A cross B contains 4 elements. Therefore, number of possible relations is equal to 2 to the power 4. This is equal to 16. Alright. Now this is given a relation. Write the domain and range of relation. Domain, I told you, the set of first element 1, 2, 3, 7. So you write domain equal to the set of first elements 1, 2, 3 and 7. What about range R? Range R containing these elements 3, 5, 5, 4. So just arrange and write, because you cannot take an element twice. So it will be 3, 4, 5. How to write this kind of relation? A is given this way, B is given this way, relation from A to B. So how to find it? The elements are related in such a manner that their sum is equal to 8. Will you get any element where sum is equal to 8? 6 plus 2 equal to 8. 5 plus 3 equal to 8. So xy will be accordingly. So that the sum of two elements will be equal to 8. So we can write it is 5, 3 and 6, 2. So DOMAR this time is going to be 5, 6 and range of the relation is going to be 2, 3. Next one, number 16. A is given, B is also given, be two sets, and R is to be a relation from A to B. Then R inverse is this. Inverse means if the actual relation going from A to B, inverse should be from B to A, nothing else. So in R inverse, the first element must be taken from which set? From the set B. That's why you see C, D, D, E. It is taken from there. And its range will be taken from this set A. That's why elements are taken this manner 1, 1, 2, 2. So is this an inverse relation? Can this be relation from B to A? Because C, D and E belong to this, and here also you have taken C, D and E as the first element. So this is alright. There is no problem in it. Now the second element, it should go to set A, that is 1, 1, 2, 2. 1 and 2 belonging to this. So this is going to be a true statement. Alright. This statement is true here. And the next one, if R is given this way, write R inverse. This you all can write R inverse. Listen to me carefully. If you need to solve these sums on your own, I'll always suggest you to revise the basic concept of the chapter and the formula if there, and then you start practicing these. Once I'm showing you, but you can practice all these sums again. Now set A is this. Relation R defined in the set A as AB belonging to A cross A equal to 2B. Then range of the relation R will be what? So range will be the set B, and it is given A equal to 2B. A is taken from this set. It is defined on set A. So both will come from set A only. Both means both A and B will come from set A. Since A equal to 2B, so B equal to A by 2. You take the values of A in such a manner that B becomes an integer, because this set consists of integers only. So if you have taken A equal to 1, it is not possible. If A equal to 2, then B is 1. It is possible. Am I correct? So relation you write this manner. R equal to that AB part you are writing. You have taken A equal to 2, then B is going to be 1. If it is 4, it is 2. If it is 6, then 3. If it is 8, then 4. And if it is 10, it is going to be 5. Okay? So this way you can solve the problems. Range of the relation then R is going to be what? That 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5 is not there. So I think that the other option is there, where you will find either it is none of these or these elements will be given over there. Alright.